If you watched any of the Khan Academy videos on rearranging equations, you'll notice that I'm using the same examples to do the unit analysis. That's because the unit analysis is for checking rearranging equations to make sure that you've done it correctly. It's a quick and easy way to check your work, and we'll show you whether or not the logic that you used made sense. So here we're just going to look at the units on the original equation. The area is the base times the height divided by 2. And then we're going to compare it to the result. Height is 2 times the area divided by the base. And when we do the unit analysis, we always put the units in square brackets just to show that it's not actually variables we're putting in here, they're just units. So area, generally speaking, is going to be in meters squared. Let's assume base and height are in meters, so that means area is meters squared. So that's the left side. And the right side is base times height. And then it's divided by 2. But 2 doesn't have a unit, so when we do the unit analysis, it doesn't even appear in the equation. And we also know that m times m in a normal occurrence would be m squared, and it works the same way here. So meters times meters is meters squared. So that tells us that our original equation made sense. And now we're going to check the result here. So height is in meters, and let's find out if that's equal to the right side. Again, that 2 is unitless, so we're going to ignore it. The area is meters squared, and then we're dividing by the base, which is meters. So we have meters squared divided by meters, which helps us divide out part of that, and it leaves us with meters. So again, the right side is equal to the left side, and our equation appears to be sound. Another example that contains addition this time instead of multiplication. We're going to work through the same way. I'm going to stick with meters just to be consistent. So let's say the perimeter here is measured in meters. So that's our left side. And the right side we have 2 times the length. Well, 2 again, unitless. We're going to ignore it. So length is in meters plus 2 times width. Width is in meters. So I've got meters plus meters. So I want you to think just like when you're doing combining of like terms in math. So if I had 2x plus 2x, you would tell me that I had 4 x's, right? So we're combining like terms. Well, when we combine units, it works in a similar way in that if the unit is the same, you're allowed to add them. Now, we're not going to have this whole coefficient doohickeys, right? So we're not going to see this part. But you are going to see that if you're adding 2 of the same thing, like when they're x's, you're allowed to add them together. So here we've got meters and meters, so we're allowed to add them together, and that means that we still have meters. For instance, if I did 2 meters plus 3 meters, well then I have 5 meters, so we're still in meters. So we're good with our original equation. We can see that the units on the left side match the units on the right side, and let's just double check the result to make sure that it also works. So length is in meters, and I want to find out here if it works in our answer. So perimeter is in meters. Minus 2, we're going to ignore that 2. Remember, it's a constant, it doesn't matter. And the width is in meters, and that whole thing is divided by 2, again a constant that we can ignore. And similarly with the subtraction here, as with the addition on the other side, we're allowed to subtract things that are the same, which means this subtraction is allowed to happen, and we still have a result of meters, so we're pretty confident with this result here. The bottom of this page here, I'm just going to give you some of the common ones you'll see on the page used to do the work on this section of the lessons. Just so you know, every time you see an M, it's representing mass, so that's going to be in kilograms. Every time you see a V, or a V with a subscript, it's representing speed, and that's in meters per second. And every time you see an A, that's acceleration, and it's in meters per second squared. And the D is distance, and that's in meters. So those are the common ones you're going to see on the sheets.